Before we can measure anything, and before we can think about the units that we are measuring something in, we need to know what it is that we are actually measuring. Now, there are tons of different things in the world that we could try and measure. But we are going to focus in on 4 different types of measurement, 4 different quantities that we can measure. And those 4 quantities are distance, weight, the amount of liquid, and temperature. Now, the next thing we need to do is we need to know what different units we could use to measure those 4 different things in. So let's generate a big list of all the units that we might need somewhere, and then we'll sort them out. So here is a list of units. Now, these units are either distance, weight, amount of liquid, or temperature, and they are all units that we are either going to talk about in this video or you might need to know something about for this course. Now, some of these units we need to know a lot about, some of them we only need to know a tiny bit about, and some of them we don't really need at all, but they will help me make certain points in this video. But let's have a go at sorting them out first of all, and then we'll focus in, work out which ones it is we need and which ones we don't need, and so on. Let's have a look at distance first. Well, let's pick out one of the classic distance measures. And let's say that meters are a measure of distance. We've probably all seen a meter stick before. So meters are the distance from one point to another, the amount of space covered from one point to another. Now, if we're picking out meters, there are 3 other units in that list that we might also want to pick out as well. In fact, 3 other units that contain that word meter somewhere in there: millimeter, centimeter, and kilometer. And if we're saying that meters are a measure of distance, whatever they are, however long that is, it sort of makes sense that the other 3 with similar word endings would also be units of distance. So centimeters, millimeters, kilometers in there as well. Other classic units of distance. Well, we've got feet and we've got inches. Feet and inches tend to be used to measure height. Classically speaking, we talk about being a certain number of feet and a certain number of inches tall. But surely height is just the distance the top of your head is from the floor. It's a vertical distance, but it's still a distance. The other 2 classic distances that we can see in this list, we've got miles, used to measure the distance between 2 far off places, say 2 cities or 2 countries maybe, and we've got yards, often used to measure closer distances. That's it for distance. Now, there are other distance measurements that exist. We don't need to focus on any of the others. These are the 8 that we might need to mention somewhere. Let's have a look at weight now, units of weight. So that could be weight of a person, or it could be weight of an object. The classic exam type uses of weight might talk about cooking or baking, those kind of things. So if we're thinking about weight, well, we could weigh something in kilograms. We might talk about ourselves being a certain number of kilograms in weight. And if we're picking out kilograms as a unit of weight, it sort of makes sense that we pick out grams as well, because they are, well, similar word endings again, aren't they? The other kind of weight measurements that you might see, well, you might measure your own weight in stones and pounds. Or you might see in cookbooks, in recipes, pounds and ounces. So stones, pounds and ounces can also go on our list of weight. 2 more that we can pick out. Well, we've got this word tons, the T-O-N-S, and we've also got this T-O-N-N-E-S one. Tons are also a unit of weight used to measure the weight of very heavy things like cars, for example. Why are they spelt differently? Well, there's presumably a reason why. We'll see why in a little bit. But tons and tons, both pronounced the same, but spelt differently for reasons that we'll come to shortly, both units of weight. Again, there are more units of weight that exist, but these are the ones that we might come across somewhere. We have a look now at amount of liquid. Well, think about a small bottle of fizzy pop or a small can. And you might see that it's measured in millilitres, a certain number of millilitres. Now, if we're picking out millilitres, it makes sense that we'd also pick out litres and centilitres there because they've got this similar word ending. The other classic liquid measures, we might talk about gallons. In particular, gallons used to measure the amount of petrol, say, the amount of fuel that we might be looking at. And we've also got pints, used to measure the amount of milk or the amount of beer. And then we're left with 2. We're left with Fahrenheit and we're left with centigrade/Celsius. Centigrade and Celsius, 2 different names for the same thing. Centigrade and Celsius are just two different names. I will talk about why there are two different names very shortly, but both of those nicely are units of temperature. So now that we've sorted these out, we've got some of them are units of distance, some weight, some liquid, and some temperature. There's a little extra level of sorting that we can do, because it turns out that some of these, and I'm going to colour these in green, are what are called metric measures, whereas some of them, the other ones, the ones in orange, are what are called imperial measures. Now, before we talk about what they are, there are just a couple of these that we don't really need to know an awful lot about. Well, the ones that we don't need to know too much about, it turns out that we don't need to know very much about yards. We don't particularly need to know very much about the two different types of ton, although we will come back to those later in this video. And we don't really need to know an awful lot about centilitres either. So let's just quietly lose those, leaving ourselves with a nice list of green metric measures and orange imperial measures, all of which we might need to know something about for the exam. But then, of course, what are metric and imperial measures? Well, in a very, very basic sense, the metric measures are the modern measures, the ones that we should be using nowadays, whereas the imperial measures are the more old-fashioned ones. The ones that if you went back, if you thought back, perhaps if you are a little bit older, if you think back, they might be the ones that you are more used to using, more familiar with using. So around about the 60s and the 70s, the UK government decided to make a shift towards using the metric system rather than the imperial system. It was always the case that the imperial system had been the one that the government favoured in terms of international trade, that kind of thing. But in the 60s and the 70s, the government decided that we needed to shift to a metric system. As the world was opening up and more countries around, particularly Europe, were using the metric system rather than the imperial system, particularly close neighbours like France were using the metric system, we decided that we would also shift towards the metric system. So it was that meters, centimetres, millilitres, litres, etc., the metric system started being taught in schools, started being used as the standard for international trade. Problem is, we never quite shifted away from using the imperial system. We still use the imperial system quite comfortably. If we think about liquid measures, for example, we might use litres and millilitres for fizzy drinks, but we still use pints for beer and for milk. And we never quite moved away from imperial measures. Look at recipes. You will get ingredients given to you in grams, and you will also get ingredients given to you in ounces or millilitres and pints. You still get both systems. The metric one comes first because we are apparently a metric system country, but the others still get used. We talk about distances in meters, centimetres, kilometres, those kind of things, but we are still quite comfortable using feet and inches to measure our height, using miles to measure the distance that we've gone on a journey, that kind of thing. We still talk about miles per gallon if we're thinking about fuel consumption in cars. But when you go to the doctors, you will not be asked for your height in feet and inches. You would be asked for your height in centimetres because we are a metric system country. So this idea of metric system measures being the newer ones and imperial system measures being the more old-fashioned ones isn't perhaps the best way of defining them. It's just a bit of a rule of thumb. So then the question is there a better way of defining the difference between metric measures and imperial measures? Well, it turns out, yes, there is. It is worth noting at this point that you need to know much more about the metric system than you need to know about the imperial system. You need to be able to take any metric system measurement within one of these four groups and convert it to the others. So, for example, you need to be able to know how to convert between meters, centimeters, millimeters, kilometers, between kilograms and grams, between milliliters and liters, and you need to be able to do that without being told the conversions. The imperial system, you just really need to recognize the different units that are being mentioned. You may have to convert between them, but you will be told the conversion. So really, for the imperial system, you just have to be able to recognize what type of measurement something is and know how to convert. as in the process, the method, not the actual numerical conversion. So that means our next step has to be to focus in on this metric system and look at the conversions and find out how to convert from one to another.
Now it turns out it's not quite as difficult to work out these conversions as it might seem. We're going to focus in on the distance ones first of all, and we're going to think again about that meter stick. Now that meter stick is exactly 1 meter long. But if we look very closely along its length, we find that nowhere on that meter stick does it actually say the word 1 meter. Nothing tells us that it is 1 meter long. We just know that it is 1 meter long, because in fact there are completely different numbers that are marked on it. Where at one end we have a 0, all the way up to, well, it goes 98, 99, and then the end of the meter ruler. So right at the end would be number 100. And what those numbers are, the 0 through to the 100, they are centimetres. So these two measures, 1 metre and 100 centimetres, 1 metre is how long the meter stick is, but 100 centimetres is how long the meter stick shows it is. These two things must be the same. 1 metre and 100 centimetres must be the same. Now that should not be that surprising, thinking about the name in there. In particular, thinking about this word centimetre. The metres part of the name is the same, but cent we have seen before. We talked about cent when we were thinking about percent. And when we were thinking about percent literally meant out of 100. So centimetre, cent means 100. That's why they are called centimetres, because 100 of them join together to make this distance metre. It's worth pointing out at this stage that actually this idea of a metre is a completely artificial thing, or in fact any of these measures. It's just that someone has chosen, for distance say, a certain distance and said, I'm going to give a name to that. So someone chose that particular distance would be called a metre, and then split it up into 100 little bits and called them a centimetre because there are 100 of them. The whole thing is a completely artificial idea, as is true for any measurement. Someone just picked a measurement and said that's what we're going to call this particular name. So the name centimetres absolutely makes sense. So for every metre, 1 metre is the same as 100 centimetres. If we now look at a ruler, this 15 centimetre ruler, for example, we can see that between each of the centimetres, so that's the 0, the 1, the 2, the 3, the 4, the 5, and so on, between each of those are little lines. How many little lines are there between each one? Well, to get from any given centimetre to the next one, we have to make 10 jumps. That means there are 10 divisions within each centimetre. And each of those divisions, there is a little bit of a clue there, each of those divisions is a millimetre. So it turns out that 1 centimetre is the same as 10 millimetres. And all we've done is counted some lines on a ruler to find that. Now for this third one, we should actually be able to put these two pieces of information together. If 1 metre is the same as 100 centimetres, and each one of those centimetres is the same as 10 millimetres, we should be able to work out how many millimetres there are in a whole metre. So if we've got 100 centimetres, and between each one of those is 10 millimetres, we should have 100 lots of 10 millimetres. And 100 lots of 10 is 1,000, and 1 metre is the same as 1,000 millimetres. One more that we need to know. We can find a fact involving kilometres. That was the last of our metric measures within distance there. And it turns out that 1 kilometre is 1,000 metres. There's no real way of knowing that other than just knowing it. But actually that's 4 facts, and really we only need to know 2 of them. One comes from a definition, one comes from counting on a ruler, this one comes from putting those previous 2 together, and this last one, maybe we do just have to know that and remember that 1 kilometre is 1,000 metres. Final thing we can add to this, well, it turns out that all units of measure have a certain symbol associated with them. Well, for metres we use the symbol M, so 1M, and centimetres 100 cm. cm for centimetres. 1 centimetre, so 1 cm, is the same as 10 mm for millimetres. Millimetres. Metre again is the same as 1,000 mm. And 1 kilometre, no prizes for guessing what that's going to be. 1 km for kilometre is 1,000 m. So m for metres, cm for centimetres, mm for millimetres, and km for kilometres.
So now that we've found these conversions, we can actually use these 4 to help us find a couple of other ones that we need to know. We think about the liquid volume ones. Well, we can use certain properties of the words metre, centimetre, millimetre, kilometre to help us fill in some of these extra ones, the liquid volume and the weight ones. Well, if we know that 1 metre is 1,000 millimetres, then surely it follows that 1 litre would be 1,000 millilitres. And similarly, if 1 metre is 100 centimetres, then surely 1 litre would be 100 centilitres. Because there's that patterning in the words. That cent, once again, means 100. It turns out that milli, in much the same way, means 1,000. And just as the distance ones had nice symbols, the liquid volume ones also have nice symbols. So we use L for litre, ml for milliliter, and cl for centiliter. But of course, we did say before that centiliter was one we didn't particularly need to know about. That's still true, so let's get rid of it. It's worth mentioning because it's worth pointing out that that centi kind of pattern follows through. But it is true that the only liquid volume conversion we really need to know is the litres to millilitres. But again, it's just an extension using some word patterning of the distance measures. Now we could use the same kind of word patterning to look at the weight ones. Now I've called these mass here rather than weight. There is a very particular reason why, and we'll see that in a future lesson much further down the line. For now, we're going to accept that they are called weight. It's worth pointing out that they are actually more properly called mass, and again we will see why later on. But for now, just think of them as weight units. Now with the distance units, we had that 1 kilometre was 1,000 metres, and it turns out that 1 kilogram is 1,000 grams. And again, there's some nice symbols that we can use kg for kilogram and g for gram. But again, the patterning just follows. 1 kilometre is 1,000 metres, 1 kilogram is 1,000 grams. And there's one more that we can add to this. We did mention them earlier, and again, we don't need to know that much about them, but it turns out that 1 tonne is equal to 1,000 kilograms, and we do use a capital T for tonne. We don't particularly need to know that one is about to disappear, but it's worth pointing that out, that 1 tonne is 1,000 kilograms, because we did say we would start explaining what these tonnes were and why there were 2 different ones. But now that we've got that, we're going to get rid of it because it isn't one that we need to know an awful lot about. But there we go, 6 facts. Now, hopefully we're looking at these conversions and we're starting to notice a little bit of a pattern. The pattern and the similarities between them might be even more obvious if we just have a glance at a couple of imperial conversions. So if we're looking at these imperial conversions, not going to go through every single one, just a couple of examples just to tip you off. Some of the ones that we might actually have heard of possibly, and a couple that we might not. We think about a foot, 1 foot and 12 inches are the same. There are 12 inches in 1 foot. We've also got that 1 stone is 14 pounds. And it also turns out that 1 pound is 16 ounces. From that, we could work out how many ounces there are in a stone. We're not going to, but we could do. We've also got that 1 tonne, this is the imperial tonne now, is 2,240 pounds. And then the final one we're going to mention is that 1 gallon is 8 pints. Now I'm going to bring up the metric ones again. Look at the difference between the numbers in the metric measures and the numbers in the imperial measures. The ones in the metric measures are all quite nice. They're tens, hundreds, thousands, those kind of things. Whereas the numbers in the imperial system are not. We've got a 12, a 14, a 16, an 8, a 2,240. They're all over the place. And we can also have a quick look at the symbols. It's worth noticing the symbols. So the symbols for the metric, the M, CM, MM, KM, the L and the ML, the G and the KG. There's some nice kind of patterning going on there, nice kind of mirroring. If we have a look at a couple of the symbols from the imperial system, well, FT for feet, that does sort of make sense actually, and IN for inches, that seems reasonable enough as well. But then pounds is LB, because of course it is, and ounces is OZ, because of course it is. And so really, earlier on when we said that the metric system are the new ones and the imperial system are the old-fashioned ones, really that was too basic. Really we can say something much more nuanced, much more clever. Because actually, it turns out that the metric measures are all based around the hundreds, tens and units system, whereas the imperial measures aren't. The metric system was deliberately designed to be nice and easy to use, to all fit together nicely, to be based around these tens, hundreds, thousands, the powers of 10. Because lots and lots of things in maths are, and we like tens, we count in tens. So it was all designed to work, and it was designed from scratch, which is why all the symbols kind of mesh up. Whereas the imperial system was not designed from scratch. The imperial system is a little bit of this, and we'll bolt that one on, and then somebody's invented this one, so we'll shove that one in there as well. The numbers are all over the place because they are so many different things that have been shoved together into a system. So properly, the metric measures are all based around the hundreds, tens, units system, and the imperial measures are just a mishmash of loads of other things. We've got one final loose end to tie up. Here is a thermometer. This thermometer is measuring in degrees C. That's centigrade or Celsius. Celsius because this whole system was invented and named after a chap called Anders Celsius. So it takes his name and becomes degrees Celsius or degrees C. But it's often called the centigrade system because Anders Celsius decided that what he was going to do is he was going to base his units of measurement, and remember that any unit of measurement is a completely artificial thing. Somebody has decided to look at a certain property, a certain amount of something, and say, we are going to give this a name. And he said, I am going to call the point at which water becomes ice 0 degrees C. So he looked at water, and as it became ice, he said, that's what I'm going to call 0. And then he looked at water as it became steam. And the point at which water boils to make steam, he said, I am going to call that 100. Why? Because 100 is a nice number. And it's quite big as well. So the point at which water freezes to become ice, he said, that's what I'm going to make 0 degrees C. And the point at which water boils to become steam, I'm going to make that 100 degrees C. And then there are 100 divisions, 100 counting steps, I guess, in between those 2 points. And so that's why it becomes known as centigrade, because cent means 100. The little block of metal that you can see there under the jars is a kilogram. Or rather, to be more precise, this is the international prototype of the kilogram. So in 1889, this little block of a platinum alloy was defined as what a kilogram is. And they said this block of platinum alloy, 90% platinum, 10% iridium. Some scientists decided that, and it's based on the number of atoms in there, that block is what everybody was going to call a kilogram. Now, the original kilogram, the original block of this, is kept in a lab just outside Paris. And the idea was that countries from all across the world would turn up, make copies of their own that had exactly the same mass, weight, whatever you want to call it, and they would take their own copies back. So there are quite a lot of copies of this, and different countries had them in their own labs. Now, until 2019, so that's 130 years pretty much, until 2019, this was used as the international standard for calculating the kilogram. And every now and again, people would go back to the kilogram, they would recalibrate their own copy and make sure that it was still the same. Now, the problem is, every time you handle this kilogram, and they tried to reduce the number of times it was being handled, but every time you handle this kilogram, you slightly change it. Because everything is made up of atoms, and every time it was handled, the surface layer of atoms changes. Because either you brush a few off accidentally, or you add a couple of extra on, you change their alignment, and slowly, over time, the kilogram starts to degenerate slightly. Equally, as do all of the copies around the world, because they may be being handled differently. So the copies start to deviate from the international standard. And this was becoming an increasing problem. After 130 years of use, the kilogram was actually starting to be slightly lighter than it used to be. So in 2019, some scientists sat down and they worked out a way of defining the kilogram without having to use a physical object. It's now done with electromagnetism and electromagnetic properties. But for 130 years, from 1889 to 2019, this was used as the standard way of working out a kilogram.
So there are plenty of different ways that we can think about these unit conversions. They all start with the same first step, and that is to write down the thing that we're actually using, the conversion that we are using. I'm just going to focus in on meters to centimeters for this, because actually they're all basically the same process. We just need to be able to convert from the start point to the end point. So you could just substitute out the right symbols and numbers. So if we start from the fact that 1 meter is 100 centimeters, and that's our first step, write down the conversion that we're using. Different ways that we could think about it. Well, the first way we could think about it, we could think about it in a kind of sound it out sort of way. 1 meter is 100 centimeters, so 2 meters is 200 centimeters, so 3 meters is 300 centimeters, so 12 meters is 1200 centimeters, and so on, in a kind of sounding it out kind of way. Now, admittedly, that only works for whole numbers of meters, but we could still do it in that kind of way. Next thing we could do, we could notice that if 1 meter is 100 centimeters, we might spot that to get from meters to centimeters, we have times by 100. Or we've divided by 100 to go the other way. Some of you might appreciate that kind of very hard and fast, this is the actual maths that we're doing. To find our number of centimeters, we've times by 100. For the different conversions, we might have times or divided by a different thing, but remember that with the metric system, it will all either be 10 or 100 or 1,000. The next way we could look at it, we could use stuff that we've done before, ideas that we've encountered before. We could start with our basic fact, 1 meter is 100 centimeters. Say we wanted to know how many centimeters 5 meters was. Or we could set this up as a how have we got from the first fact to the second fact. Well, to get from 1 meter to 5 meters, we need to times by 5. So if we've times the number of meters by 5, then we would also have to times the number of centimeters by 5. Then we do 100 centimeters, times that by 5, and get 500 centimeters. This kind of setup might look a little bit similar, and in fact I could, if I wanted, change these equals signs to ratio dots. And that would still be perfectly fine. We could also use a process of building up towards the answer, using facts that we know or can easily find out, to build towards something that we don't know. Let's say we wanted to work out ultimately 2.56 meters, converted into centimeters, and work out how many centimeters that needs to be. Well, maybe we can't go straight from the 1 meter to the 2.56, because timesing by 2.56 is not the easiest thing to do. Maybe we could find some other facts that are nearby, and we can use them as clues to help us get towards this answer. Well, we know that 1 metre is 100 centimetres, so it must be the case that 2 metres is 200 centimetres. So we know that 2.56 will be somewhere around about 200 centimetres. We also know that 3 metres is 300 centimetres. Now 2.56 falls somewhere in between 2 and 3. So the number of centimetres must be somewhere in between 200 and 300. We could even fill in 2.5 metres. Well, 2.5 metres is exactly halfway between the 2 and the 3 metres, which means the number of centimetres for that will be exactly halfway between 200 and 300, and will be 250. And if we know that, 2.5 is 250, so 2.56 will have to be 256 centimetres. And it is worth pointing out that the 2, the 5 and the 6 are present in both cases. All the same digits will be there. The most that will happen is you could either gain or lose some zeros, or you could gain or lose decimal points. But the digits, the important digits, will all still be there in the same order. So the 2, the 5 and the 6 are in the same order. It's also worth saying that we knew we were looking for a hundreds number here. If we knew that 2 metres was 200 centimetres, the 5 and the 6 would have to follow, giving us the 256 either way. So this idea of using clues to find something that we don't know, using what we do know to find something we don't know. You could also use a kind of double-sided number line idea. And this idea is particularly useful if you are dealing with a question like this. So we've got that 1 metre is 100 centimetres, and I have got on the top of my number line 100 centimetres, 0 to 100, and on the bottom 0 to 1 in metres. So I've got centimetres on the top, metres on the bottom. You could do them the other way around, of course. Either is fine. And then I want to write 25 centimetres in metres. Now this question should immediately ring a bell as being a little bit different. First of all, because this time we're starting with centimetres and going into metres. In the previous ones we were starting with metres and going into centimetres. Here we're starting with the centimetres, switching to metres. But the next thing to notice is we've got 25 centimetres. Well, that is less than 1 metre. How do we know? Because 1 metre is 100 centimetres and we've got a lot less than that. We've only got 25. So clearly we're going to have 0 point something metres. Now we could see on the number line what that's going to come out as. Well, if 0 to 100, the halfway point is going to be 50 centimetres. The halfway point in the metre is going to be 0.5 metres. So 50 centimetres is 0.5 metres. Now we've got 25 centimetres, so we're narrowing it down. But in drawing it out, it's perhaps easier to see. If 50 centimetres is 0.5, then presumably 40 centimetres will be 0.4, and 30 centimetres will be 0.3, and 20 centimetres will be 0.2. And suddenly, we want 25 centimetres. Well, it's going to be somewhere between 20 and 30. So it's going to be somewhere between 0.2 and 0.3. The 5 is not going to just disappear, so our answer will have to be 0.25 metres. And notice that in going from centimetres to metres, just to loop us back round to the beginning, we have done a divide by 100, because centimetres to metres will have to divide by 100. In the same way that going from metres to centimetres times by 100. Now I appreciate that those approaches were quite quickly delivered. However, that's because this is the kind of thing where you really have to pick the way that you're going to do it. And I've shown you several different ones there. There are others as well. You could have a bit of a play around, see what patterns you can spot for yourself. They're all very adaptable, but you're always going to start off with the basic conversion. The best way to do is to just have a look at a good few questions, and the more you do, the easier it will get. Try the different methods out for yourself and work out which one is the best one for you. Work out how you're going to set things out. Have a look at some examples already given to you. And try and spot patterns. Try and see for yourself what the best way of understanding how to get from one number to the other number is. And if you work it out for yourself, you should then be able to do it anytime for any conversion. But again, for any of these, you start with the conversion. The conversion being written down is the first step and always the first step. Personally, I would suggest you maybe have a look at the ratio type setup. the idea of scaling one side up, scaling the other side up, either with equals or ratio dots, because we've used ratios quite a lot, and we seem quite keen on them, and we will be using them later on in the year for other things. So I would personally suggest the ratio kind of idea, but that doesn't mean you have to do it that way. There might be other ways that you prefer. So converting within the metric system that we've just seen, again, to reinforce this, you have to know the conversions. You have to know how to convert between the different metric units. The imperial units, you might be asked to convert between, but you will always be told the conversion, in which case you start by writing that down. For example, given that 1 foot equals 12 inches, work out how many inches there are in 4.5 feet. So this time we are working in imperial units, we're working in feet and inches, and we are told the conversion. We are told that 1 foot equals 12 inches. And then we are told to work out how many inches there are in 4.5 feet. Now again, we've got lots of different ways that we could do this, but one way we could do this as a kind of scaling up both sides ratio type question. And if we've gone from 1 to 4.5, we have times by 4.5. Doing that on the left with the feet side, we have to also scale up the number of inches by 4.5. So we're going to do 12, we're going to times it by 4.5. Well, 12 times 4, 12 plus 4 is 48, and the 0.5 will give us half as many as 12, so that will be 48 plus a 6 is 54 inches. And 4.5 feet is 54 inches.
If we were to look at this 30 centimetre ruler, say, we know it's a 30 centimetre ruler because on the top we've got centimetres from 0 to 30. If we were to look at the other side of this particular ruler though, we can see that we've got inches from 0 to 12. And we've just seen that 12 inches is 1 foot. So that means that 1 foot and 30 centimetres are, well actually they're not equal. They are roughly equal. 1 foot is about the same as 30 centimetres. In fact, if you look very closely, you can see that the 12 inches is actually slightly longer. It turns out that 1 foot is the same as 30.48 centimetres. But we tend to say that, roughly speaking, 1 foot and 30 centimetres are about the same. But that's not an exact conversion because they're two different systems. But we could use it as a rough conversion to switch from a metric measurement to an imperial measurement, if for some reason we wanted it as a different type of measurement, a different system. So you could get a question involving one of those rough conversions. For example,
given that 5 miles is roughly equal to 8 kilometres, convert 40 miles into kilometres. So this is one of those types of question. We've got a metric measure and an imperial measure, and we're given a rough estimate of the conversion between the two. We are told that 5 miles and 8 kilometres are roughly equivalent. So we can say, as far as the question is concerned, 5 miles equals 8 kilometres. And then we are asked to convert 40 miles into kilometres. So we add the 40 miles down there as well. And there are lots of different ways that we could do this question, but we could do it with this kind of scaling up sort of idea. To get from 5 miles to 40 miles, we have times by 8. And if we've done that on the left-hand side, the miles side, we could do the same on the kilometres side. So we could times by 8 there as well. If we do 8 kilometres, we times that by 8, we are going to get 64 kilometres. And if 5 miles and 8 kilometres are roughly equivalent, then 40 miles and 64 kilometres are also roughly equivalent.